Hi everyone, in this lesson we are going to study how to graph rational functions or rational graphs. So A will create a vertical stretch if A is more than 1, and B will create a vertical shrink if B is more than 1. Okay, X minus C, so this means the graph either goes to the right or to the left. If it's minus, goes right. If it's plus, goes left. So don't forget it's opposite of intuition. And D moves the graph up or down. So let me go over a few things here. So as always, from the previous functions, if you have a negative lead, then that will create or cause a reflect of the graph over the x-axis. Okay, so the graph will be reflected over the x-axis, and the C value moves the vertical asymptote. The equation will always be x equals C. As you can see here, if you set x minus C equal to 0, then solve for C, so that means x equals C. The D value moves the horizontal asymptote, and the equation will be y equals D, always. Okay, so for the next few examples, list the transformations of each rational function, and let's see, given the direction and amount of movement. So for example, number 1, we have the equation is y equals 1 over x plus 7 minus 5. So as you can see, plus 7 means it's going to go to the left 7, and the minus 5 is going to go down 5. And the second example, the equation is y equals 6 over x minus 8 plus 10. So first, the 6 is going to create a vertical stretch by 6, and then minus 8 in the denominator. That means it's going to go to the right 8, and then plus 10 is going to go up 10 units. So then example number 3, we have y equals 2 over x 1 over 2x minus 4. So there's a vertical shrink by 1/2, and then it's going to go down 4 units. Okay, and then number 4. So this one here has a negative in front of it, so that's going to cause the graph to reflect over the x-axis. And then the 7 is going to create a vertical stretch by 7. And x plus 3 means the graph goes to the left 3 units. Okay, so that's all for examples 1 through 4. Example number 5. So for number 5, we're being asked to graph the function below. So it's the function y equals 1 over x plus 2 minus 3. Write the equations for the asymptotes, state the domain and range using interval notation. So then, since we see an x plus 2, that means c is equal to negative 2. So the vertical asymptote has an equation of x equals negative 2. And then the horizontal asymptote is the value of d is negative 3, so then it's y equals negative 3. So then let's sketch the graph with this. And if you watch the previous video, a short video on graphing the parent function, the rational parent function, we have a vertical asymptote at x equals negative 2. So that's this line here. And then we have the horizontal asymptote at y equals negative 3. Okay, so don't forget how we got these points. We got this point by going left 1, down 1, because it's negative 1 over 1. So that's negative 1, and then right 1, up 1, because it's 1 over 1, again, if you go to the parent function. So then this is what the graph looks like when you sketch it out. So then the domain, this arrow on the blue graph goes to negative infinity, but then approaches the vertical asymptote at x equals negative 2. So then we can't get past that because there's a discontinuity here. But then there's a union, because from negative 2, we see the graph go again on the other side and then go into positive infinity. So that's domain. Range, the graph goes to negative infinity if you look at the blue graph, and then approaches negative 3, which is where the asymptote is located, and then appears on the other side from negative 3 going to positive infinity. Okay, so that's all for example number 5. Example number 6, I'm going to show you the graph and also the answer. So the equation of vertical asymptote is x equals 4. The horizontal asymptote is y equals negative 6, which is the d value, so c and d values. And then the graph, when you sketch out the asymptotes, this is the vertical asymptote, x equals 4. And this is the horizontal asymptote, y equals negative 6. And then domain comes from negative infinity, approaches 4, which is where the vertical asymptote is located, and then union with from 4 to positive infinity. The range comes from negative infinity, approaches the horizontal asymptote at y equals negative 6. Okay, so this is one side of the graph. And the other side, from negative 6, it goes to positive infinity. And that's all for number 6. Number 7. So for this one, we have a negative in front of the 1. So then the graph, notice this graph, this is how it is without a reflection over the x-axis. and this is with the reflection over the x-axis. So now they switched. So then for this one, what you do is, if you want to understand this visually, I mean, we can also do the table real quick so you can see it. So we have x and y values. So we use -1 and +1. When x is -1, y is also -1 because it's -1/1. When x is 1, y is also 1. But now we are going to change the sign of the y values because of that negative. So then this becomes +1 and this changes to -1. So now we're using these values for y. So then if I go left 1, notice up 1. So there's this point here. And if I go right 1, then down 1. So if I go right 1 from here, and there is that point, and this is why the graph looks like this. Okay, so then domain from -infinity to -3, that's where the asymptote is located. Then from -3 to +infinity. The range goes from -infinity again, approaches the asymptote at y equals 1, and then it shows up on the other side from 1 to infinity. So that is all for example number 7. Example number 8. So for number 8, we have a 3, so there's a vertical stretch by 3, and then it's going to go left 1 and down 2. So that means the vertical asymptote is at x equals -1, so that's this line here, and the horizontal asymptote is at y equals -2, so that's this line. And then, as you can see from the graph, well, before I go into the graph, okay, so how did I get the graph? So notice, usually go left 1. If I go left 1, then it's -1/1, so y is -1. But we're multiplying that by 3 because we have a 3 instead of a 1. Okay, so then multiply the y values by 3, so this becomes -3. When x is 1, y is 1, but multiply that by 3, so then x is 3. So that means from this point, if I go left 1, then I have to go down 1 and 2, right? Because of that right there, that 3 in front on the numerator. If I go right 1, then I multiply that 1 by 3, so I need to go up 3. So that's how I got the graph. So then if you look at the graph, this goes to -infinity and then approaches a vertical asymptote at x equals -1. So that's one side of the graph, and then the other side shows up on the other side of the asymptotes. So it goes from -1 to +infinity for domain. For range, this comes from -infinity, approaches the horizontal asymptote at y equals -2, but then it shows up on the other side and going from -2 to +infinity. And we'll do this one in class. We'll discuss this one in class. Okay, so let's go to the other side of this paper. So on this side, write the equations for the asymptotes, state the domain and range using interval notation, do not graph. So we're not going to graph at all for these examples. So remember, the asymptotes cause breaks in the domain. Okay, so there's a discontinuity there in the domain and the range. So only the C and D values affect the asymptotes. So don't forget, C moves left and right, D moves up and down. So for number 10, so this is asking us to write the asymptotes. So the vertical asymptote, if we set x minus 7 equal to 0, then x equals 7, there is the vertical asymptote. And the horizontal asymptote, in this case, there is no value for D. That means D has to be 0, so the horizontal asymptote is y equals 0. Now, if you know the asymptotes for both vertical and horizontal, you can write the domain and the range. Because domain is going to come from -infinity, get to the asymptote, the vertical asymptote, and then approach that value, then union with that value again, and then continues to infinity. The range, the asymptote, the horizontal one is y equals 0, so then it comes from -infinity, approaches 0, union with from 0 to infinity. Okay, so that's the other side of the graph. So that's example number 10. For number 11, there is a 4, but in this case, we just want the vertical asymptote and horizontal asymptote and also domain and range. So since we do not have plus or minus with the x, then the vertical asymptote stays at x equals 0, but we have a minus sign for D, so that means the horizontal asymptote is at y equals -9. So then domain is from -infinity, comma 0, union with 0 to infinity, and the range comes from -infinity, approaches the horizontal asymptote, and then on the other side is going to be union with -9 to +infinity. So that's all for examples 10 and 11. For the next part, write a rational function matching each description. So this says the parent function f of x equals 1 over x is stretched vertically by a factor of 4. So there is that 4. Okay, so this is that 4. And then translate it 2 units up. So that means this means that part. So plus 2. And then 7 units left. Since it's 7 units left, we must have a plus. So, so this should be plus, right? So that should be plus, and then reflected over the x-axis, so that means you must have a negative in front of that 4. So this is that graph that represents the transformations done to the parent function. The next example, part B. F of x, the parent function f of x equals 1 over x, which is the rational function that has a vertical asymptote at x equals -6. So that means there should be plus 6 in the denominator with the x, and a horizontal asymptote at y equals 9. So that means d is 9. So plus 9 here, and that's all. So then this has to be the function that represents the transformation of this parent function for the rational. Okay, and that's all for this lesson. I'll see you in class. Bye-bye.